Okay. So if we look at the book here, it gives us some examples. So we're creating this, creating an object. All right. So now, remember when we talked about the difference between procedural languages and object-oriented languages? We use that example of a telephone where the procedural, kind of what we've been doing up to this point, is a big pile of wires. So think about our code up to this point where, every single class when we, did either the solution of the homework or did some new stuff, whatever it was, at the end of class, we kind of had this hodgepodge of functions and stuff like that. Then down at the bottom when we tested it, we were testing it in terms of the functions we had up there. So we called a couple different functions in a couple different orders. And so it was a lot of individual moving parts. What we want to do is we want to take all those wires and stuff them into the phone, stuff it into an object that we can then pass that object around and say this guy has some abilities. All right. So we're going to start off with I'm going to call it a player object based on the direction we're going to go with this guy. So we're going to create a class called player. All right. Now we're going to say that a player is going to have, for right now, let's say he has a first name and a number of hit points. All right, because we're going to kind of make this a little gamey type thing. So if you, so the idea is hit points is like your amount of life you have left, because we're going to have two players fighting each other until one of them croaks. All right, so we're going to give them some random number of hit points, but initially we'll just give everybody 10 hit points. Keep it simple. All right, well, so when we build a player, ultimately I want to have this object. I want to say, okay, I want to build one player named Mike. I'm going to build another player named Dave. Okay, and so this player, his name is Mike, and he has 10 hit points. And this player, his name is Dave, and he also starts with 10 hit points this time around. Okay, we're not randomizing those things. But I want to have a single blueprint for this, but be able to create two separate objects from that. And in order to do that, we need this specialized kind of method, specialized kind of function. And this guy is called a constructor. Okay. Now, these are words taken from real life. We need something who does the initial building of our object. Okay. So when you think about real life, you hire somebody to build your house, right? So he has this blueprint. So he has this, this big piece of paper in front of him that kind of tells him how a house gets built, right? But ultimately, he's the one who does the building. So you hire a contractor or a constructor. He comes over and he takes that blueprint and says, okay, maybe he needs something from you. All right, he might, for instance, in this case, we're building a player. So he probably needs that player's name. Okay, so tell me the name of the player I'm building and I'll do the rest. I'll set the name and I'll give him 10 hit points. That's what he's going to do. Okay. So now if you look at, this is that special function, this guy, def underscore init underscore. Okay, and we'll talk about the rest of these pieces. So let's go into here. I'm going to say def. Is it one underscore or two underscores? Two? I think it's two. And then this guy takes in something called self. All right, looks like it's probably two. All right, let's say it's true. All right, so now what we're going to do, again, this is a loosely typed language, so we don't predefine our variables. So the first time our variables are coming into existence are right now. But self, let's give a definition of that guy. Well, let's say a constructor initially builds an object given 0 or more parameters. So right now we have no parameters, but I'll set parameters here in a second. Now, part of what happens when we build this is a new variable is created, and it's part of the syntax for object creation in Python. And it's this parameter called self. In other languages, well, let's give a definition to it first. So self is how an object refers to itself from within itself. That's what that variable is all about. Okay, we have this variable called self. It's similar to in real life how when we refer to ourselves as me or my. Okay, my name is Mike. Okay, so in this case, we would say self.name. When an object wants to talk about his own name, he would say self.name. If somebody else was talking about me, they would say, that guy's name is Mike. Okay, they're not referring to themselves, they're referring to the actual object that's standing over there. Okay? So, in other languages, so Java, C#, C++, actually a lot of other languages, but let's leave it at this. Instead of self, it's this. Those are equivalents. So this dot is, in Java, how an object refers to itself from within itself. So next semester, when we're writing Java objects, doing Android stuff, we'll see that we use the this keyword instead of self, but they accomplish the same thing. Swift, as well as a bunch of other languages, uses self. We saw Python uses this. Visual Basic, which is the one outlier, uses a variable called me, which is kind of dumb, but nobody uses Visual Basic, so it's okay. Okay, so these are all synonyms. They all mean the same thing. This is just the variable that is part of the syntax for that language that allows an object to refer to itself from within itself. Make sense? Muaf, you skipped the hackathon.
Oh, I couldn't make it.
Did you let anybody know?
Oh, I texted the group early, but nobody responded.
Oh.
I said I might be late, but
Because you were on that same team, weren't you? Were you on Nick Largen's team, I think?
No, we were supposed to work on the HoloLens.
Oh, you were on Josh Curcio's team.
Yeah, I think Josh.
Yeah. Blew it. All right, so, but in Python, we're using the keyword self. Now, in this case, we don't just want, so self has to come in. Self gets passed around on any object in Python. Okay, it comes with it. All right, that way we have inside here, we have a local variable that allows this player to refer to themselves. But we also said that we want a name. So in order for this constructor to build a player for us, we have to pass in self. That's not actually something that we're going to pass in physically. It's just something that magically happens. It's part of the Python syntax for creating objects. But we are going to have to tell it the name of the player we want him to build. All right? And then what we're going to do here is we're going to say self.name is equal to name, whatever was passed in. Self.hp is equal to 10. Something like that. Okay? So that is the constructor for this player. Now, before we do anything else, let's go ahead and let's create a player. So we'll say P1 is equal to player Mike. P2 is equal to player Dave. Then I should be able to do P1 dot name. We'll print out that guy's name. We'll say P2 dot name. So give me the name of player 1, give me the name of player 2. After asking the constructor to build us a player, passing it Mike for name, and build us another player, passing us Dave for name. So that particular player, P2, internally refers to himself as self, just like P1 internally refers to themselves inside as self. That's no different than when I refer to myself, I say me. When you refer to yourself, you say me. Those are two separate me's, right? When you say me, you're talking about you. When I say me, I'm talking about, from your perspective, you. You. All right, so that variable travels along to these different objects and allows an object to talk about itself from what's in itself. So when this constructor is building it, I am setting my name equal to whatever name was passed in. I'm setting my hit points equal to a hard-coded value of 10. All right, let's go ahead and run this guy. So there's Mike and Dave, proving that those players know how to report their name. Make sense? Now, what we can do, just kind of going down the line here, I can create another method inside of this player object, and maybe we'll call this method display. And display needs to take self in as a parameter. That's kind of like a constant part of the syntax for a player. Notice I never passed anything special here other than just the name. It magically gets passed in so that we have access to this variable. Similarly, when we call display, we don't actually have to pass it anything. It's part of the syntax. So for display, why don't we go ahead and we'll print out self.name concatenated with, maybe a space followed by a colon, concatenated with self.hp. All right, so now a player knows how to build itself. It also knows how to display itself. It's an ability of every player. So every single player knows how to display themselves. So I can say p1.display and p2.display. That make sense? Oh, I got to remember we can't use concatenation with strings and integers. So I have to turn that guy into a string for this concatenation thing. Or make the other one an int, but converting Mike into an int is going to be problematic. Okay, but I can convert 10 into a string. That'll work out all right. And interestingly, though, in most strongly typed languages, we could have done what we did before. Because it would have figured out that that second guy was an int and still been able to treat the plus sign as the concatenation operator. Whereas in a loosely typed language, it doesn't determine the type until runtime, since that type potentially could change. So it actually then makes this kind of inconvenient where we have to say, oh, well, I know this guy happens to be holding a number right now. Since I want to concatenate it onto a string, I need to go ahead and convert that number into its string form. So there's our player 1 displayed himself, player 2 displayed himself. Make sense? Okay. Let's see. How do we get a random number in Python? We did it before, didn't we? Is it just random? Or is it arc random?
You'll get a random number?
Yeah.
The way I know is to use random and then put the range between the two.
Python 3 random number. Yeah, so we should be able to just do random. Yeah, here, randint. This guy?
Yeah.
So we would say random.randit.
Mm-hmm.
All right. And then give it a beginning and end. So maybe instead of a 10 here, we do random.randint.
You'll need to import random at the start of the program.
Okay, we'll do that here in a second. I think random might come with it if I give it this full path like this. I guess we'll find out. And let's see, what's the minimum number of hit points somebody could have? Maybe 5. And maximum maybe 15. So we'll say 5 to 16. 16 should be non-inclusive. All right, so the hope would be if I create 2 different players, it's going to give me 2 different, hopefully 2 different number of hit points, unless a crappy dice roll, right? We got 11 twice or something like that. Let's see if it's going to force us to import given the, yep, it does. All right, so there's Mike and Dave, 8 and 16. If I run this guy again, I'll probably get different values. So each time I run this, this guy's getting, well, there was a 7 and a 7. Okay, but we're getting a randomized number of hit points. Correct? All right, so we have 2 guys now, player 1, player 2. Now, we want these guys to be able to fight each other. Okay, so this is going to be a very violent class today. Now, in real life, to various degrees of maybe competency, we all know how to engage somebody else in a fight, correct? You run up, there's usually an initial name calling and then a shove or something like that, and then you just start swinging or scratching or biting. I'm a biter personally, okay? But, the point is that I can either attack one of you or you can attack me. Somebody starts the fight, correct? And they engage in that fight with somebody else, potentially multiple people. But so what we're going to do is we're going to teach each of our players how to fight another player. That makes sense? So we can decide who we want to start the fight, but whoever starts the fight probably throws the first punch. That's usually how it works, right? And then the other person fights back, whatever. All right? So we're going to go ahead and inside of here, we're going to say def fight. So we're going to have a method called fight. And like all of our methods that live inside of classes, this guy will have self as the first parameter that will magically get passed in. But when a player fights somebody, who do they fight? We need to pass this guy the person that they fight. So what kind of animal am I going to be passing into this fight function? Another player. Yep. So we just invented a new type. So we've known about integers, we've known about numbers, we've had floating point, we've had integers, we have strings, we had floating point numbers, we've had some booleans, trues and falses. Now we just invented our own type, player. So we're going to call this guy. Maybe we'll call it. We can call it player all lowercase. That's okay. Probably a decent variable name for this, since we want to. Nothing stops somebody who's using our code here from passing in a number here for player, but we want to strongly encourage them to give us a player in order for us to accurately fight. Okay, otherwise we're fighting inanimate objects and it doesn't work so well. All right, so we'll name that variable that we want them to pass in. We'll name it player, but you could have just as easily named it elephant, then passed in a player. Okay, so we're expecting them to pass in a player. Now, we want the players to be able to attack each other. So when we start a fight, okay, we got two players dancing around. What do? They attack. So if I'm throwing the first punch, I attack the player that was passed in. So self. So the way I refer to myself in here is self is going to attack player, which is another player. So self is a player. It's me. It's this player right here. And whoever I'm in the fight with is going to be referenced through a variable called player here. All right. So if me and you are in this fight, okay, and he's going to have speed on his side. I'm obviously going to have mass. Okay, so he's going to have to zip around until I just get worn out and have to sit. But in any case, so I'm self when I'm talking about it in here. He's player when I'm talking about it in here. Okay, so maybe I throw the first punch. So I need to have a way of generating an attack, right? So that's probably going to be like an amount of damage, right? That I need to generate. So probably another random number. So maybe an attack is going to be in the range of, 1 to 4? Something like that? 1 to 4. 1d4 damage. Yeah, exactly. 1d4 damage. So we're getting to a little bit of tabletop Dungeons and Dragons stuff. So we'll roll a d4 to get that. I like the direction you're going there because that's going to be our second object. All right, perfect. So for right now, we'll use what we know about generating a random number. So we'll say random dot, actually, let's just say we'll create a variable here. Damage is going to be equal to random dot randint of 1 to 5 non-inclusive. So this will give us a 1 through a 4 randomly. So that's the amount of damage that self is going to inflict on player. Are we following these two different variables? Self and player are both instances of the player class. But self is the guy who started the fight in this case. Player is the guy who was thrown into the ring, passed in as a parameter here. Okay, but both of those guys are players. So now I want to inflict amount of damage on player. That's what self's thing is going to be, right? Okay, so how do I do that? how do I inflict, how does self inflict amount of damage to player? What does that mean? What does it mean for, let's say it's 3. I'm doing 3 damage to you. So when I do 3 damage to you, what's the net effect? What actually occurs to you? Yeah, your hit points go down, right? Okay, but it's not self.hp. Self.hp would be like, I swing and I miss and I hit myself and right? So I want to say player.hp is equal to player.hp minus damage. That's how I'll hit him. If I say self.hp is equal to self.hp minus damage, that means I hit myself. That makes sense? Okay. Now, why don't we create a couple of, we want to kind of start moving towards modular programming here. So why don't we write some methods that allow us to inflict damage on another player? Okay, so we're going to create a function, and we'll call this guy def inflict damage. So it's always going to be self, and we're going to pass in the player that we want to inflict damage to. And then let's also pass in the amount of damage that we want to inflict. All right. So what do we do here? We're going to say player.hp is equal to player.hp minus damage. So whoever I'm inflicting damage on is going to have his damage reduced, or his hit points reduced. Does that make sense? Okay. So we calculated damage here. Now I'll go ahead and say self. So I want to inflict damage on him. So I'll say self dot, I want to call my ability to inflict damage, passing in the amount of damage that I just calculated, as well as the player who I want to do that damage to, or to whom I wish to do the damage. Go ahead.
Why not have a method which is receiving damage, and you can have one less parameter?
Absolutely could. Well, actually, you would still have. Oh, well, you could do that. So he wants to do. We have an inflict damage, and then we want to have a receive damage method that takes in the amount of damage that we're going to receive, and we'll say self.hp. Self.hp is equal to self.hp minus damage. Something like that.
Yeah.
So then what he wants to do here is he wants to
Do a bit less typing.
say, well, actually, in that case, we would say we would say player dot receive damage. So you want, well, no, this doesn't really save us anything, because you would say player dot receive damage. So he just took, I told him to take the damage rather than having me inflict the damage. Okay, maybe one makes more sense than the other, but I'm not sure we really saved much typing. So I can either inflict the damage on him. Now, I see what you're saying. You want to do maybe something like this. When I inflict damage, I still need to have the player I'm going to inflict it to, but you can take this then and put that in there. So instead of having that there, we can put that like that. So when I want to do damage, I'm then going to say self.inflict damage. How much damage? DMG amount of damage to player. What does inflict damage say to do? It says take the player who I'm inflicting damage to and have him receive some damage. How much damage? The damage that I inflicted. So that other player will then have his receive damage method get called, which will take in the amount of damage that he's receiving, and he'll subtract his own hit points. All right, so let's kind of think through this, because self and player are both players, but they're different players. Okay, so we're going to do a little role acting here. So him and I are in a fight. All right, so in this case, I started the fight. So initially, self inside a fight, I'm self, you're player, right? Okay. So let's say I'm going to do 3 damage. So I've rolled the dice. I got 3 damage that I want to do. So I'm going to inflict 3 damage on you. So I'm going to call my internal ability to inflict damage, passing it 3 damage and passing a pointer to you, to that guy. Okay? Now, what do I do in there? In there, I tell you, I say, okay, I need you to now receive 3 damage. Okay, so now we pause it on my side. So now the tables turn. Now we're inside his object. So when he goes to receive the damage, he will have his version of receive damage called. Inside of that, when he says self, he's referring to himself. So when he thinks self, I'm thinking player. That make sense? So he's calling his receive damage method. That is, the receive damage method owned by player is taking some damage. And then his hit points will reduce. Now, after we receive damage, we probably want to maybe return back, maybe whether or not we're dead, or something like that. Or we can maybe write another function, def is dead, and is dead returns self.hp less than or equal to 0. So it'll return true if my hit points are 0 or less, false otherwise. That makes sense? Okay. So in a fight, and we're going to call this a fight initially, but in a fight, I'm going to basically just keep beating him down until he drops. You know, this isn't a two-way street. This is one of those, like in the UFC, when the one guy gets on top and the other guy stops fighting back and they're just doing the swings, you know, that guy. All right. Well, I don't know. I would wear out after 1 or 2 punches. Yeah, that's when you watch UFC, that's what they always do. The little guys, they keep zipping around, right? Until the big guys wear out. In wrestling, same thing, right? I mean, you know, that's why you have the weight classes. So a big guy gets a hold of you. If you wrestled up, then you might be in trouble. But if you can dance around getting him worn out, eventually he's just going to lay down and let you pin him. So that's the trade-off, right? All right, so what we're going to do in here is, as long as you're still alive, I'm going to keep beating on you. All right, so we're going to throw a while loop in here. We're going to say while. Now we've given a method here for is player, for a player to determine whether or not they're dead. So while not player dot is dead. So while that player is not dead, we're going to do some stuff. This is the same thing as saying while player dot is dead returns, is it false like that? Returns false. Okay, those say the same thing. Okay, so while the player is not dead, or player dot is dead is equal to false. All right, so while the player is not dead, we're going to go ahead, we're going to calculate some damage, then we'll inflict that damage on him. Okay, then why don't we go ahead and have the player report back his current status, all right, and see how things are currently going. So we'll say player dot, what we taught him how to display, player dot display. All right, so we have our 2 players, and actually, why don't we do this? When we start a fight, let's give the initial status. You know, we'll have each of the players display themselves so we kind of know what things are looking like at the beginning. All right, so if I want to display myself in here, how do I display myself? Self dot display. I already have a function for doing the display stuff, right? And I could write it again, but I might as well call upon the function I wrote that knows how to display things about me. So I'll display myself, and then I'll ask the player to display themselves. Make sense? So we'll give the initial status, then I start the beatdown. So we'll say P1 dot fight P2. All right. So the fight method takes in a player as a parameter. So P1 is going to start a fight with this particular player. And then we're going to watch the mayhem unfold. Okay. So let's go ahead and run this guy. Is not like that? Is it just the word not?
I got a syntax on the exclamation.
Yeah, that's what I got too. Is it that? The other one would have worked in Python too. Yep, that's what it was. Yeah, I remember same thing with the ands and ors when we did it initially. In Python 3, it's the word and, the word or, and apparently it's the word not as well. All right, so we started off the fight. Oh, I had more hit points anyways. All right, so then you drop the 4, then 2, 3 punches, you were gone. All right. Now, realistically, though, there's probably a fight back. So whoever starts the fight probably throws the first punch, right? Maybe we decide that we make the amount of damage could be 0 in case they swing and whiff, but let's make them do some damage right now. Okay, so what we're going to do now is, as long as the person's not dead, we need to be able to toggle back and forth. Okay, so who's going next? So the first time through, I'm going to generate damage, and I'm going to have self inflict damage on player. The next time through, I want to have player inflict damage on self, assuming the guy's still alive, right? So we can't just do it 2 in a row. We need to actually toggle back and forth between player 1 and player 2, or self and player. All right, how might you do that? What strategy might you use to toggle? So now we're solving the problem in real life of whose turn is it? The whose turn is it problem, right? Go ahead.
Would you call player dot fight and pass himself within the fight function?
You actually could. And he would only fight as long, but he doesn't check to see if he's dead. He checks to see if the other guy's dead. So in that case, we could have a dead guy throwing punches.
Right, but then you also have the other guy.
Yeah, the other guy has a fight, has his fight function. So after I throw my first punch, let's say he died on the first punch. Randomly. Okay, he had a low number of hit points. I hit really hard. He's dead. Well, before we determine that he's dead, we're going to tell him to fight me. And what's he going to do? He's going to say, okay, I'm dead, but I'm going to still throw a punch. My opponent, not dead. So, not dead. I'm going to go ahead and have my dead corpse-like body generate an amount of damage. Then I'm going to inflict that damage zombie style on my opponent. Probably not going to, but that approach isn't necessarily a bad approach. You just have to put in the correct if statements in there. More than likely, if we're thinking about this kind of in how objects might interact, once I start a fight, the fight kind of keeps going. And I didn't start the fight just to have him start the fight back, right? Not that you couldn't make it work. But again, remember, programming languages, they try to solve problems the way we solve them in real life. Okay, so I've started the fight. I throw the first punch. You're either alive or not after the first punch. So the second punch, just to be fair, let's say, is going to be you. So we need to have a way of knowing that the first guy to fight is going to be self. The second guy to fight will be player. The third guy to fight will be self, then player, then self, then player, then self, then player. So we need to have the ability to toggle back and forth between those two guys. So some different strategies we can use for this. We could say maybe we have a variable that keeps track of whose turn it is, and maybe we do it on even and odd numbers. Okay, so maybe self goes on odd numbers and player goes on even numbers. So we can have a variable here called turn. Start that off at 1. And we'll always calculate damage if the guy we're attacking is not dead, right? Well, actually, we really want to have both things in here, right? We want to say this guy's not dead and the other guy's not dead. Or something like that. Or we can put another if statement in here. Okay, so while both guys are still kicking, so while that guy's not dead and not self dot is dead. So that while loop now says while both of us are alive. Okay, while both of us are alive. Let's throw a punch. Okay. Now, the reality is that somebody could be dead, but they may have just died. So we only actually do a fight. We only actually need to generate damage if everybody's still alive. Correct? This is a true statement here. So while both combatants are standing, we're going to have the guy who's up next generate damage and throw a punch while both of them are still standing. Once one of them drops, we're done throwing punches and somebody died. Okay? So we'll always generate the amount of damage here, but now we need to ask whose turn is it to inflict damage? If turn is an odd number, we'll say that it's self's turn to do it. So we'll say if turn mod 2 is equal to 1. That says if that guy's an odd number. Then we'll go ahead and have self inflict damage on player and then have player report their current status. We'll also have to say turn is equal to turn plus 1. That way the next time through it's the other guy's turn. Else, okay, if turn is not an odd number, it must be an even number. Therefore, it is player's turn to inflict damage. How much damage? Damage amount of damage on self. On the other guy. Or on me, I guess. Then I'll say self dot display. And turn is equal to turn plus 1. So we'll just keep incrementing. You could also, if you want to go back and forth, you can do turn plus 1 and turn minus 1. It'll just toggle back and forth between 1 and 2 to 1 to 2 to 1 to 2. Either one of those will work. The advantage of toggling between 1 and 2 is in a situation where we have a lot of hit points where a fight might last a long time, probably wouldn't happen, but you potentially could run out of numbers. And it'll actually zero back. Then it'll go negative and things might break. This guarantees we'll never run out of numbers. We always just go from 1 to 2 back to 1. Okay? So as long as both players are standing, generate damage, decide whose turn it is. If it's an odd turn, I will inflict damage on player, have the player report his status, increment turn. If it's an even, have the player inflict damage, report to me, report myself, increment turn, or decrement turn to go back. So this should now have a complete fight.
Oh, yes. I will.
All right, so we both start off at 7, even fight. Both went down to 5, then 2, then 3, and finally he lost. That make sense? All right, so for next class, I'll give you this as a sample. We're not going to augment this yet, but what we want to do is we want to write a dice. We're going to create a little dice object. And a dice has a number of sides. Okay? So you can have a 4-sided dice, a 5-sided dice, a 10-sided dice, a 20-sided dice, whatever it is. And when you roll a dice, so when you roll a 6-sided, in real life it's called a die, but when you roll a 6-sided dice, it gives you a value between 1 and 6 inclusive. A 4-sided dice is 1 to 4. 20-sided dice is 1 to 20. So what you should be able to do is you should be able to create a dice with a number of sides and then roll that particular dice, and it should give you, each time you roll it, a number between 1 and the number of sides. Does that make sense? All right. So I'll put that up on, I'll put this code up on Slack. I'll put that up on Blackboard, and I'll see everybody on Wednesday. And then next time we'll incorporate our dice into our fighter thing. And then we probably need to put these guys in a dungeon, right?
If we wanted to drag it on, we could put it in a company